Backup software. It looks like a good one. It's only $40 a year.
$40? I thought you were a programmer or something. Can't you make something on your own? We're not that rich. I mean, the cash simply doesn't flow off of trees, you know. Oh my god, this guy.
I guess I'm making software.
Ow! I'm studying! I promise!
But backup software is just a tool that anyone can make, yet they charge an arm and leg for it. Maybe they charge you a yearly fee just to have the option to restore a backup that they've stuck in a format that you can't access any other way. It really is just a for loop, a queue, and a little bit of time in order to make your own, and just having a secondary place to store stuff if you have to wipe your computer. It's not that difficult. So this video is going to go over some basics that you need to know of how this process works, and then we'll go into some code at the end, get some basic framework that you can use for pretty much any project you want, and really use C# because it's a simple language for a simple program. So the obvious reason to have a backup is you might have important files later on that you need to keep hold of, like pictures or movies or important documents for medical history, things like that. Well, if you have one computer and one hard drive, that hard drive dies, you'll lose everything. Or the hard drive gets stolen because your computer got stolen, your house got broken into, or there's a fire. So there's the less obvious and less likely reason to have a backup, but it doesn't make it any more necessary in that moment when you actually need those files again after everything is gone. So having a backup is kind of important. Other than your house burning down, then another one is like, hey, I'm going to use a RAID because that will preserve all my data. That's not a backup solution. That's just a longevity and reliability solution. It doesn't solve the problems like I already mentioned. So the other option is do that, but if you have malware come along and corrupt all your files or encrypt them so you have no access to them anymore, well, now you have a whole hard drive filled with stuff you can't use. And you're going to have to reformat it anyways because the virus is persistent and it will just keep coming back over and over again. So again, a backup is kind of important. So an easy definition of if a file needs to be updated or not is has the number of bits in the file changed or has the date of the class modified changed. Between the two, it's a pretty good representation of if the file is updated or not. There's also the unusual thing where a new file has been generated. If there's a file that's been renamed, well, it's a little harder to deal with, and I can kind of get into that in the optional section of this video. But one of the things that a lot of backup software will do is they compress the files after it's done. It's a good tactic. It actually reduces the file size, so less hard drive space for that backup. But it also introduces the problem of having to decompress it in order to get the files back out. It also prevents things from being changed. But that also means that you have to use their software to get it back out again, which is a bit of a problem if it has a yearly charge. And it's easy to do from Windows. If you have a command line or PowerShell, you can actually just put a command line in and compress things down without even having to worry about it. It has the same difficulties where you have to decompress in order to get it back out again, but it does save hard drive space. And software is easy to inject command lines into the Windows. But the problem again is that if you have a thumb drive that you're going to put everything on, most of them are in a FAT32 format, which has a maximum limit of 4 gigs per file. So you have to reformat your thumb drive if you have a large zip file. And that becomes a real problem. Most people don't even realize it's an issue until they try to put a file on there and it won't go for some reason. So if you want to do that, you can. Just make sure that that particular format that you're putting onto the drive is some kind of 64-bit format like NTFS, for example. You don't actually have to have like a cloud or a NAS to do any of this off-site storing. All you need is a second computer, like a laptop or an extra computer sitting off to the side. Windows, by default, all you have to do is turn on the sharing like I have up here, and you can easily do file sharing at that point. All you have to do is look through the little option scrolling up the side. In the file manager, you just type in / the computer name or the IP address, and it goes right to it, whether it shows up in the little network section at the bottom or not. If you're trying to connect to a Linux box, you have to use the IP address as far as I know, because I can't get it to show a network name. some reason. It's something in Windows that just kind of prevents it, as far as I know. So Linux is great as a file server sitting off to the side. You back up old hardware, and it's free because the operating system is free. But RAID 1, what it does is it has a fake location that looks kind of like a separate drive all to itself. What it does is it masks other hard drives that are completely invisible to the main computer. And when a file goes into that fake one, then it copies the file from one place and also to the other place. When it pulls those files back out, because somebody asks for them, it pulls it from one drive or the other depending on how the software works. So using that idea, we're going to have files in one location and we're going to copy them into another place. And if it's different, then we're going to copy it over. And if it's not, then we're going to leave it alone. It doesn't need the new copy put on top of it. We'll save some time with hard drive wear. The rest of this video is going to be a simple tutorial looking through this little algorithm off to the side. Overall, it's just a queue, and inside the loop, you just keep going through as long as there's something inside the queue. And every time you find a new folder, you can look at all the subfolders underneath it and feed it right back into the queue. As it processes through, every time it finds a new file location, you just compare it to the target location. If it's different, then you move files back and forth as needed. And every time it finishes off that subfolder, it removes itself from the queue and it grabs the next one. It continues until the queue is empty. It never goes back to the same location, so it works out pretty well. No recursion needed or any kind of fancy tricks. It's just a queue and a loop. So to start with, you need to have a start directory and an end directory. It's going to be a type string where it's just the full path, like C:/Windows, for example. I've done some serialization, so I can load these from a file. So you normally wouldn't need these nulls, but it's an advantage if you have a serialization because it needs to be cleared out properly. Then we're going to build the actual directory info, which will end up creating the actual folders that these are going to go to and read from if they don't already exist to prevent errors, and then actually make directory info for both locations. What directory info has is all the links to folders and files for the particular directory given, and it's stored in a type that makes it easy access. We'll use this quite a bit. Windows also has this nice little option of creating a directory if it doesn't exist. Just make sure that you have right access to that folder before actually trying to work with this. It's probably something to check just in case, but we'll have a try-catch type statement wrapped around it. To start this process, we're going to take a link from the previous section that I showed you, and we're going to start processing it. First thing we're going to do is we're going to take the particular item that was passed in, and we're going to temporarily store it into a list of all the known folders that we have. And then we're going to take the very first item from that list and store it temporarily, and then add that particular item into a good list of all folders that have been processed along the way. This will make sense shortly. And then for every subdirectory inside of the particular directory we're looking at, we're going to get all the directories and add them to that temporary list I mentioned before. We have a start path, an end path. We're going to assume that the end path is going to be underneath the folder that we have in the path that we already had here. We're just going to add the subdirectory name to it. That's this path.combine command. So we're just going to assume that we're going to make the directory structure exactly the same on both ends. You don't have to do it this way, but it's the easiest way to understand and process at this point. We're going to make a new path in that piece I showed you in the last segment, and we're going to store that particular path into the temporary location. And that's going to be done for every subdirectory underneath that particular folder. And then now that all the subdirectories have been added, we can look at all the files inside of that directory in the first place. We're going to keep the start directory and get all the files from it. And then we're going to take that file and we're going to do some stuff with it. I'll show you in the next segment. Once that is done with all the files, it moves to the next list location and will continue until all the temporary folders have been processed, which returns us back to the beginning, goes to the next folder, and so on and so forth. And before this overall list of all processed folders, we can take this list later on and actually just process it for reporting measures. For this overall process, it's not required, so it can be removed. It's more of these reporting and status updates to the user as the whole process runs. It can easily take a long time if you're working across a network or some other method that's a little slower, the files are large, things like that. So reporting can be useful, and that can be used for this piece here. File item I mentioned, I have a why everything was changed portion here, which helps the whole process along. I'll make sense shortly. And a bunch of other variables that help out the process as well. You're going to need the start location, end location, and so on. In the main constructor that I use, I have file names, the paths that I'm going to be using, pulled off of the directory info because it has that. Then I'm going to compare the files, and if I want to have them sent immediately, I will send those particular items to the end location that I've determined. So the end path from the start path. The compare is quite simple overall. In my method, I've made sure that both of the file locations actually exist. And if they do, I go ahead and store the file info about that. So it's going to have things like when it was created, and the last time it was modified, and the overall file size that we want to have for comparison. The first thing I'm going to do is check the overall length. It's just pulling the length off of this file info. And I go ahead and store that. And it's stored in the overall number of bytes inside of the actual file. Because it's such a small number, it's very unlikely that a small change in the file will not show up in this particular length item. Then all I have to do is compare to make sure the links are identical. If they're not, then I can go ahead and show that it's not and process that shortly. I've also added extra features like determining why it was different on one end versus the other. Mine is only one directional, so I don't have to check both, but you can easily check both directions and report that back as well. Then I can go ahead and check the last write time. That's going to be the last modified date. That shows up in Windows properties. And that's usually pretty accurate. All I have to do is exactly the same process. If they're not the same, mark it. One is newer than the other, mark that as well. After I've processed the length and the last time it was modified, I can start processing why it was changed and if I have to do anything about it. So I've made all these little different options for marking out what happened along with it, mostly for reporting. You don't have to do all these extra items, but you just have to make sure that it's noted that the file actually did change to some other status that needs to show that it's been updated, maybe which direction you want to have it moved as well. When you actually do the send, make sure that you're looking for the file actually is different. If it's not different, just go ahead and stop the process right away. Make sure that the file actually exists that you're going to be writing from. So don't want to work with nulls. That's one of the issues with C# is that nulls can exist. If you're moving one file from one direction or the other, then you want to check for both sides. In my case, I don't care because it might be a new file. And then all I have to do is actually copy the actual file location and then set the creation time and write time to the value of the actual original folder so I can check it back later. I know if it's been modified or not, so I know these are the same. This is a very important step. You'll notice that this whole thing is captured inside of a try. What that means is if you have start locations not accessible or can't copy it to a new location, then the whole thing is going to error out. The try will capture that with an exception. I can report the error some way from the console or into a program, and it won't error out and crash the desktop with this try statement. If you don't have write access, for example, the file doesn't exist, you don't have this try, the whole program crashes the desktop and the whole process has to be restarted. This kind of skips that whole error. So going back to the original loop, after we have done all the processing and moved the file if necessary, we're actually going to only use this particular method, so we always can be true. Moves to the next folder, starts over, and then continues on the whole process. Very simple. That's the whole process for doing a backup. For manually mirroring one drive to another, there's nothing fancy, no reason to purchase software. One of the options I had mentioned before was to do compression along the way. So you can have the console.execute command run that particular command, or you can have it access to the PowerShell. Also with C# you have access to system.io.compression, which makes it so you can do all the compression stuff from within the program itself. Another option you can work with is actually outputting all of the processing that happened into some external file. For example, I use OpenXML, which can produce Excel sheets or Word documents or whatever you need. Excel works out really nice. You can also just output to a general TXT file, separate things by commas, however you want to work it. Another option that's probably very useful is going to be having some kind of early exit or pause feature. That's going to have some kind of check to an outside boolean to say, hey, inside the loop, if I see this to be true, then I put it into a thread.sleep command. If you have an exit, then you have it return false or true or something to exit out the whole process. And if you want to have that, usually it means you're going to have some kind of thread system, which is beyond the scope of this video, but it's going to be necessary in order to have this kind of process be more efficient and user-friendly. For things like if you have a GUI, for example, you're going to have to work with some, they call it delegate, to update the interface from a thread, otherwise it throws errors. And that will also give you access to hit a pause button or an exit. But if you work with a GUI and you have some kind of thread in the background, make sure that you actually have that extra ability to kill the process along the way. If you exit a program and the thread's running in the background, some languages will actually let you have that thread running continuously until it's completed, all the way until you reboot the computer. Another very useful feature in this is to actually have some kind of status update being exported out to the individual. That way they can kind of see where the long process is going, how far it's actually come along. So you might want to pre-scan all the folders and then have an overall count. As you go from folder to folder, you have some kind of output in order to say a percentage, for example, or a count along the way. But if you're dealing with folders that have a little bit of information in it or small files, that can actually go too fast, so that your console output will just kind of scroll as fast as it can and actually slow the process down, because outputting to a console is really slow. So you might want to do it every 20 or 30 options, as opposed to just every single one. A little more advanced feature that might be rather useful is something that Windows Server calls shadow copy. You can kind of simulate this by taking all the files that are new and having to be overwritten, and you have a secondary folder that you move those files into and maybe do a comparison there. That way you have multiple copies, so you can kind of run backwards in time in case maybe a file was changed that wasn't supposed to be changed. So hopefully you can see that making backup software is pretty simple. So paying $30, $40 a year for software you probably are never going to use, kind of pointless. So if you have any questions on any of those optional items, just go ahead and let me know in the comments below. And like and subscribe. Thanks.
Ow! I'm studying! I promise!
So don't rely on a RAID forever either. And I forgot what I was going to say. And you lose that drive, so now you're screwed. I forgot what I was going to say again. It would actually end quickly, that it wouldn't process in more extra.